Figure 1 shows the graph of the curve with equation y equals 16 over x squared minus x over 2 plus 1 for x greater than 0. The finite region R, bounded by the lines x equals 1, the x-axis, and the curve is shown shaded in figure 1. The curve crosses the x-axis at the point 40. Complete the table with the values of y corresponding to x equals 2 and 2.5. Use the trapezium rule with all the values in the completed table to find an approximate value for the area of R, giving your answer to 2 decimal places. Use integration to find the exact value for the area of R. So here's the question then, let's have a little look at it in summary form. So we've got the picture of the graph, and the table is the first thing we need to find out, don't we? So let's work these values out then. Okay, so it's 16 over x squared, so 16 divided by x, which in this case is 2 squared, minus x, which is 2 divided by 2, plus 1, equals 4, so let's put that in here. And then let's put in the next value, 2.5. So go back, and we need to, instead of 16 divided by 2, it's 2.5. Minus 2x over, so it's minus 2.5, isn't it? 0.5 over 2 plus 1. And we get 2.31 in here. Okay, now use the trapezium rule to evaluate r to 2dp. So let's paste in the trapezium rule then. Here it is here. So we've got h over 2, the first and the last y ordinates, plus 2 times all the ordinates, the y ordinates in between. Let's have a look at this then. So here's the numbers then. Okay, so we've got h is b minus a. We're integrating between 4 and 1. So b is 4, a is 1. 4 minus 1 is 3 over the number of ordinates. 4, 5, 6, 7 ordinates. So n will be 6, won't it? It's the number of intervals. Because we start from y0. So let's have a go then. B minus a over n then. Let's put that in. So 4 minus 1 is 3 over the number of intervals, which is 6. So h is a half. So h over 2 is a quarter here. So let's put that in straight away. 1 over 4. Now the first plus the last, 16.5 plus 0. Let's put that in now. I'll put it in here rather than write a new line. So that'll be 16.5 plus 2 lots of all the ordinates in between. So this one, this one, this one, and this one here at the end. 1, 2, 3, 4, 5 of them. Okay, so let's do that then. And we'll put them in here. So we've got 7.361 plus 4 plus 2.31 plus 1.278 plus 0.556. There we go. So we just need to tap that in the calculator now and work it out. So we had a quarter, which is 0.25 on the left, times bracket, and then it was 16.5, wasn't it? Plus 2 times bracket. So 7 plus 4 is 11.361, so I'm going to put that in straight away as those two numbers combined. Plus 2.31, plus 1.278, plus 0.556. I'll just put 0.556 then. Close that bracket. Equals. Decimal. To 2dp is 11.88. So equals 11.88, and that's to 2 decimal places. So use integration to find r exactly then. So our y subject is here. So I'm just going to copy that now and move it down rather than write it again. We want to integrate this now. Part C then. So we've got the integral dx between 1 and 4, wasn't it? So this is x to the minus 2. It's a power rule. So it's 16x to the minus 1, isn't it? Increase it by 1, divide by that number. Minus x to the 1, so that's x to the 2 over 2. 2 2's are 4. Plus 1 integrates to 1 lot of x. And we're evaluating that between 1 and 4. This can be tidied up, but let's just tidy it up when we write the actual numbers out. Put 4 in. 16 over 4 then is 4 over minus 1 is minus 4. Put 4 in here. 16 squared over 4 is 4. Minus another 4. And then plus 4. So that's the top value. Take away the bottom value. Put 1 in. 16 over 1 is 16. So that's a minus 16. 1 squared over 4. And then plus 1. So what do we get? We get, here we've got minus 4 for the first bracket. Then we've got 16, minus 16 plus 4 is minus 15. Plus 15 is the number, and the fraction is plus a quarter. So we end up with then 11, 15 minus 4 is 11, and a quarter, 11.25, exactly. And that would be units squared, wouldn't it?